In this question, we are asked to show that given function f which maps from a cross b to b cross a is a bijective function. So first let's understand what a bijective function is. A bijective function is something which is both one-on and onto. If it's both one-on and onto, then it's called bijective function. So first let's understand what a one-on function is. Let's say f maps from a to b. Then for any two elements a1 comma a2 which belongs to a, if a1 not equal to a2, then their images which are given by f of a1 and f of a2, these both should not be same. If a1 and a2 are same, then this can be same. And it can be alternately said that if we found out if the images to be same, that is if we find out f of a1 is equal to f of a2, then that must imply a1 is equal to a2. Only then it's called one-on function. And next let's understand what an onto function is. Onto function is something, let's say if f maps from a to b, then every element in b, that is a range set. Here b is called range set. So every element in range set must have a pre-image in a. That means it must have at least one element. That every element must have at least one element whose function is given as that particular element. Let's say b1 is the element we are speaking, and let's say b has elements from b1 to bn. So then for every b there should be some corresponding a1 whose function is given as f of a1. This must equal to b. Only then the function is called onto function. So here we are given a function f of a comma b is equal to b comma a, and we are asked to show that it's a bijective function. Let's first test it for one-on function. So if we take two random variables like f of a1 comma b1, its answer is simply b1 comma a1. So if we take some other f of a2 comma b2, this is equal to b2 comma a2. Let's say these both are same. These both are same, that implies if this equal to b2 comma a2. These both are same only when b1 is equal to b2 and a1 equal to a2. So as long as this function implies that their inputs are same, we know that the function is one-on in nature. So given function is one-on in nature. And let's say, and we have to show that it's onto term. So since in the images, not in the images, for the input we will take all the values which are spanned by a cross b. So image, if we take some a comma b, any a comma b can be any random variable, like it spans a whole a cross b, and we get f of a comma b as b comma a. That means its image is also spanning whole b cross a. So that means all the elements in b cross a are having a pre-image in a cross b. So that is our only requirement for us to show that it's onto. Therefore given function is onto. Since it's both one-on and onto, given function is bijective.